The first thing we want to do to solve this is to see if they have any factors in common. And so the way to do that in the denominators is to basically factor anything that you can. So that one obviously can't be factored, but x squared minus 16 factors into x minus 4, x plus 4. So we can see that they both have x minus 4 in the denominator, and this one has an additional factor of x plus 4. Okay, so you could think about doing this a couple different ways. Since they both have the x minus 4 there, you could actually go ahead and cancel them because both sides have the same thing in the same spot, so that's equivalent. Or you could think about, well, what if I multiply both sides by x minus 4? Well, then this side, it'll cancel out right there, and this side will cancel out right there, and that's essentially what happens. What if in addition to multiplying it by x minus 4, I also multiply both sides by x plus 4? Right, so I'm basically multiplying everything by this denominator, because this denominator includes that one and has more to it. Right, so if I multiply this side by this exact denominator over 1, as long as I do it to both sides in an equation, I'm maintaining equivalency. So I can do anything I want as long as I'm doing it to both sides. I'm going to pick to multiply both sides by this whole denominator so that this whole denominator will go away, right? So this is going to cancel this, and this is going to cancel this. So all I'm going to have left here on this side is a 16. Because I intentionally multiplied everything by this whole denominator so that this denominator would go away. And I chose this one because it's bigger, because this one is also going to cancel out this denominator. So again, I'm multiplying here, so this cancels with this, and so all I have left over here is 2 times x plus 4. Now technically, yeah, it's over 1, but we don't need to write that. So now you have a really, really simple equation to solve because you were smart about what you chose to multiply both sides by. So we can distribute 2x plus 8, we can subtract 8, 4 equals x. But we have to consider what the domain restrictions were. So up here, before we canceled these things out, we had 2 domain restrictions here, and we have 1 here. So this one is positive 4, and this one is negative 4, and this one is also positive 4. So x can't equal positive 4 or negative 4 because of the domain restrictions. But what did we just find? Our math told us that the only number that makes this equation true is a 4. But what is x not allowed to be? A 4. So if the math is showing you that a number works, but you have previously recorded, because you can't divide by 0, if you've previously recorded that x can't equal that number, it's not that either your math lied to you, it's that you're kind of in this loop where the only thing that does work is the thing that actually won't work if you plug it in, which essentially means it doesn't work, right? And so if that's the only thing that does work, well then nothing works. So this one actually has no solution, because this is what we call an extraneous solution, meaning exactly what I explained, right? That the math shows that works, but if you were to actually plug it in, it doesn't work. And the reason, the theory behind that is something to do with how we multiplied it out and whatnot. You don't need to worry about that. You just need to worry about, make sure you check your answers against your domain restrictions to ensure that you catch anything that might be extraneous.